Alright, I want to show you some new things in litdb that I've been working on. So first I want to show you the one that I'm using. So if I run litdb about here, this has, it says 68,000 sources and a little over 6.5 gigabytes. So I've spent like some time collecting references. This has over 100 authors I've followed. Lots of things have kind of come up. And building out these and finding references and citations and so forth. So today I'm going to show you some ways that I've been using it. So last time or in a previous time, showed you about this vector search, and today I'm kind of interested in using additive manufacturing to make a catalyst. So I'm just going to do a vector search for that. Alright, so right now we just focus on the command line interface. So what's happening is we turn this into a vector, we search those 68,000 references, and we get the top 3 hits that come out of this. So the top one looks like a review on additive manufacturing for materials. It sounds pretty promising, and so I might just open this. I can click on that and kind of review this, or we can look at one of these other ones. Maybe this one will work. Let's just scroll down to the references and see what I can find here. I think this one looks kind of interesting. So 3-dimensional printing for catalytic applications. So this one, there's not a DOI, and so you could click on one of these links, but one of the new features that I've added is called Crossref. So Crossref is a service where I can just paste that text in, and it will do a search in Crossref for me, and then it finds all of these matches. So these are all matches that are kind of similar, and number 0 is the one that I want to add. Right, so I can just look at this. It says 0. Down here it says enter space separated numbers. I press 0, and it's just going to go ahead and add that DOI. Now I can take the DOI over here, and let's just try to show it so we can see what it says. So that shows me it's the 3-dimensional printed catalytic applications, and it gives me a brief description of it. I can also use a command called similar. And so what similar is going to do is get this bit of text and vector embed that, and then it's going to show me the nearest articles that are similar to that, right? And so these are a few of the ones in here that are similar. Sometimes the very first one comes up. It should skip the same article because of course it's in there. It ought to be exactly the same, but it gives me some other articles that I found that are similar. So I find that pretty helpful, and let's just look at the help for this. --help. You can specify how many you want, and just for fun, let's try this Emacs option. -E. That probably is going to output these in work mode. Oh no, it's even better. Wow, better for me. It outputs this in Emacs list form. So obviously I just use that for candidates in Emacs. So I'll show you that another day. Another thing that I wanted to find and figure out how to do is to suggest reviewers. So let's say that I want to find reviewers or collaborators or something like that. And let's say, let's get this. Let's say I want to suggest reviewers for this short abstract. This study uses additive manufacturing to make catalyst pellets and coated monoliths for reactors. You could paste a whole paragraph in here. It could be the abstract of a paper you're writing. It could be something from your proposal that you're writing. The idea is you want to find people that work in that area. And so I'll go ahead and press enter here. What this does is takes, again, that sentence, makes an embedding vector, and it finds the 5 closest articles and gives you the scores here. Remember, scores here mean these are cosine distances, cosine similarity distance, so you want smaller numbers. Anything in the 0.2 range, in my experience, is pretty close. And so usually I'm okay with that. If you see numbers that are bigger than 0.5, then it says search for better matches. That will just get all of the references and citations for these. I don't need any better matches. I'm going to look at this instead. And this doesn't look super great because this table is too big for the terminal. But what it does, I'll try running it again. There, that looks a little bit better. These are people that have written papers that are close. And then I sort them by H-index, which is just a really low quality proxy for seniority. If you have a high index, you have a lot of seniority. And that's frequently what you look for when you want reviewers. These people down here with the very low numbers are probably students or postdocs or people very early in their career. But this gives you a list of people that you might look at, and then it tells you the papers down here so you can see how recent the papers were and so forth. So I find that kind of useful. You can do one where I kind of know what I might expect. Suggest reviewers. This study looks at single atom alloy electronic structure and trends across the periodic table. I'll even leave a typo in there. So I've done a bunch of work in this area and I know the literature pretty well. 0.4s are not super close, but I don't want to wait for it to go. And so here are a couple of people. Jens, Norskov, Anglos has written a lot of papers. Thomas has written papers. Hong Leon. All of these are people that I would expect could be quite reasonable reviewers for that. And then you can see down here these electronic structure designs, ordered alloys, single atom alloys, etc. Yeah, so overall, it's very useful. I don't know what this is, a super annoying warning that probably I should set an environment variable and make it go away. Okay, the last thing I want to talk about is the collaborators and other affiliations. This is an NSF table we have to write in proposals all the time. It's very annoying because they want all of the co-authors for the last 4 years of all of your papers. So I wrote a function in litdb to do that, and it just takes an orc ID. So let me find my orc ID again. litdb author search John Kitchen, and it's this one. litdb COA is the command, and I give it my orc ID. And what this does is looks up all of my papers. It does this fresh every time, so you're never out of date. And then it generates this file, which is my orc ID with the date. It's right down here, and if I double click on this to open it, let's make it a little bit bigger. This has a list. It's just table 4, but it has an alphabetized list of all of my collaborators for the past 4 years. And you do have to do a little bit of work in here. For example, here we have 2 duplicate entries. That happens for a variety of reasons, that OpenAlex may have multiple IDs for that person. You'll also find your own name in here. So my name is right here. We should just delete this row and then kind of move on. And so you can go through, clean out all the duplicates. The affiliations are not always correct. That's also a limitation. They're optional, so you can decide if you keep them or not. And then if you're ever curious, like why are there multiple entries for the 2 different TNs here? The second tab here has all of the authors, and you can see where they came from, what paper they came from. So like this is the paper that they're affiliated with. This is mostly for debugging, and then this is their author ID. And so let's look at one where there's a duplicate. So like here we have 2 for Stefan, and it turns out that there are 2 Andrew author IDs, OpenAlex IDs affiliated with Stefan. So you have to decide. You only need one of them, and again, these are just limitations of using OpenAlex for this. But it's pretty helpful. You don't have to keep up with it, and even if it's not perfect, it's probably better than any time you spend trying to do it yourself. So that's the main things that I wanted to show you today. Is the ability to suggest reviewers for something, to find similar arguments. The Crossref feature is super nice. We could even use Crossref to, let's just see what happens. litdb, Crossref, some kind of normal looking text. Here we rely on whatever Crossref search method is. Yeah, so it doesn't find anything, and obviously I need to put some code in here to fix the fact that there's no title for something. All right, well, that's real-time joy. Let's see. Seal.py. Let's see that again. So I just fixed it. Something here has no title. Who knows what it is? But you can check out the DOI if you want. Let's see. So Crossref doesn't have a title, but obviously it does. So anyway, lots of ways to check things. So thanks for coming, and we'll see you next time.